Okay, this video will be the last video of this section. And we start off with something called the theorem, named after Zachary and Legendre. I'm not sure I pronounced those names correctly. Zachary Legendre. And it says that for any triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C is less than or equal to 180. Remember, in absolute geometry, it could be that the sum of the interior angles is less than 180. In Euclidean geometry, which we'll talk about very shortly, it's always equal to 180. All right, the next example is a model for absolute geometry. It's called the Poincaré model. The space we're talking about is not the XY plane. It's just the interior of a circle. We sometimes call that a disk. Here is the circle we're talking about. I'm even going to draw it. I'm going to call that C right there. We're talking about not the circle itself, but the interior of the circle. That's the whole space. So a line can be one of two different things. It can be straight. In other words, you could draw it. You could use a straight edge to draw it if it passes through the origin. So here is one. That's the origin. Let me label the origin O. It's that right there. So that line goes through the origin, and this line goes through the origin. So those are two straight lines. But a line can also be the arc of an overlapping circle that makes right angles with the circle C. So what does that mean? Here's a circle that overlaps our circle C. And notice that where they intersect, I know they're not drawn as straight lines, but this is called a right angle. And this is called a right angle. Because right where they intersect, they're perpendicular. So this is a line from here that arcs all the way to there. That's a line. And so is this, from this all the way to this. So we're ignoring all of this, and we're ignoring all of that. So in this geometry, find two isosceles right triangles. Well, these two intersect at a right angle. This line segment, that's a line. This line segment, and then this line segment, the one that we couldn't draw with a ruler or a straight edge, that is a triangle. And similarly, on the other side, we've got this right angle. We've got this side, and then the one we can't draw with a straight edge, the one that goes along this big circle over here. Those are two right angles in the Poincaré model for absolute geometry. Okay, next example. What's a theorem? The angle sum inequality. Okay, the sum of the measures of any two angles inside a triangle is less than 180. That even holds in Euclidean geometry, because you're only adding up two of the angles. And then a triangle has blank right angles or obtuse angles. Remember what obtuse means? Right angle means 90. Obtuse means greater than 90. So how many possible angles that are either right or obtuse could a triangle have? It can only have one. And not necessarily, it may not have one. It's either 0 or a 1. So I'm going to write at most 1. And then the base angles of an isosceles triangle, what does that mean? This statement tells us? The base angles of an isosceles triangle cannot be greater than 90. They can't even equal 90. They have to be less than 90, which means they are acute. Acute angles are less than 90. Remember, obtuse angles are greater than 90. Number 8. Let's take a look at this big triangle, MLK. Notice we've got several other triangles as well in this picture. And notice that we've got this, as far as in between this goes, it goes KDEL in that order on this line segment, KDEL. So they are collinear. So we need to compare X, Y, and Z. It doesn't say solve for them because it's impossible to tell what these numbers exactly are. But we do know a few things. What do we know about the measure of angle Z? What do we know about that? Just looking at this triangle. Well, what is this? This is a right angle. That's 90 degrees. And we just learned that we can have at most one angle in a triangle that is 90 or above. That's it. So Z is less than 90. So I'm going to write up here, Z is less than 90. Okay, this is less than 90 degrees right here. And then let's use the exterior angle inequality. Okay, so let's see. Let's notice that Z is an exterior angle to which triangle? MED. MED. So it's an exterior angle, which means it's greater than the two opposite interiors. So Z is bigger than Y. Z is bigger than Y. And likewise, Y is an exterior angle of MDK. MDK, that triangle. This is exterior. So it's bigger than both of these two. So that tells us that Y is bigger than X. All right, let's write that in a nice fashion. Since we have to compare all of them, let's put it in one compound inequality. So that means that, let's see, between X and Y, we've got X less than Y. And then between Y and Z, we've got Y. I want to do something here. Y is less than Z. And then Z is less than 90. And that's all we know. I guess I could have said that X is greater than 0, so I could have put 0 less than X, but this is sufficient. This compares X, Y, and Z. All right, lastly, finish up this section. Given that the points B, C, and D, we have C in between B and D right here, so these are collinear, and AC is equal to CD. Well, what's that tell us? AC is that segment, is equal to CD, so I've indicated that these two are the same length. Prove this. Prove that Y, right here, is less than or equal to 1/2 X, or X over 2. All right, so the number 1, the measure of angle CAD is equal to what? What is this angle right here? Well, notice we have an isosceles triangle. So the two base angles, this and this, are equal. So that's Y degrees, just like that one's Y degrees. So that's Y. Now, I'm going to leave off the degrees. That's because base angles of an isosceles triangle are congruent. Well, how do we know this? 2Y plus the measure of angle ACD. So what we're doing is we're measuring these three angles. 1y, 2y plus this angle. Well, that's got to be less than 180 because of the Zachary-Legendre theorem above. All right, a couple of more steps then. What is, let's see, what is 2y What does that mean 2y is less than or equal to? That means 2y is less than or equal to, let's do algebra. Subtract that from both sides. 2y less than or equal to 180 minus the measure of angle ACD. All right, so what is 180 minus this angle? ACD. Well, less than or equal to 2y, but what's another way of saying that? 180 minus this angle is x, because these two are linear angles, they're supplementary, so they add up to 180. This one and this one. So this one is equal to 180 minus the measure of angle ACD, so x is equal to that. So 2y is less than or equal to x. And what does that mean? Well, that's easy. Next step 5, just y is less than or equal to x over 2. Done. That's the end of the proof and the end of the section.